Good morning, sir. Myself, B. Ikra Fatima from CSC A section, bearing roll number 234G1A0561. Today's my topic is recovery, and today's my topic in CAA2 assignment is recovery, atomicity, and recovery algorithm from database management system course. Recovery, atomicity, and recovery algorithm. Introduction to recovery and atomicity. Recovery is a critical aspect of database management systems, means DBMS, that ensures data integrity and consistency in case of failures. Atomicity is a principle in database transactions that guarantees that a series of operations are completed fully or not at all. Together, recovery and atomicity help maintain the reliability of data across various operations in a database environment. The importance of recovery. Recovery mechanisms are essential to restore a database to a consistent state after a failure. Various types of failures, including system crashes and hardware malfunctions, can disrupt database operations. Implement effective recovery strategies, reduces the risk of data loss, and enhance user trust in the system. So this is the figure. So first of all, database again goes to backup disk, and again this goes to database. First the backup, and next the backup disk we will go take database, and this is a restore. First we can take the database in the backup disk and we can restore in the database. Okay. Understanding atomicity. Atomicity ensures that the transaction is treated as single unit of work, which either completes entirely or not at all. It prevents partial updates to the database, which can lead to an inconsistent state. This principle is fundamental to maintaining data integrity, especially in multi-user environments. So this is a figure, atomicity, initial state. So allowed, not possible with atomicity. So the changes to be applied. And again a final state. Both the charges applied, both the charges are discharged and discarded, and next one, final state, only the one of the charges changes applied, not a charge. So this is all applied, none applied, and partially applied. Next, types of failures. Failures in a database can be classified into several categories, including transaction failures, system crashes, and media failures. Understanding these failures help in designing appropriate recovery strategies. Each type of failure requires a different approach to recovery to ensure data integrity. So this is a failure classification DBMS. Next, recovery techniques. There are several recovery techniques, including log-based recovery, shadow tagging, and checkpointing. Log-based recovery uses transaction logs to restore the database to a consistent state. Each technique has its strength and weakness, making it important to choose the right one based on specific needs. So this is a shadow tagging method of database recovery. Transaction logging. This is a database. Transaction logging involves recording all changes made to database in a log file. In the event of a failure, the system can refer to log to undo or redo transactions as necessary. This method is crucial for ensuring atomicity and maintaining an accurate record of all operations. Checkpointing. Checkpointing is a recovery mechanism that saves the current state of the database at specific intervals. By creating checkpoints, the system can minimize the amount of work required during recovery. Checkpoints provide a reference point that simplifies the recovery process in a case of failure. Shadow packing. Shadow packing is a technique that maintains two copies of the database, the current and the shadow pages. This method allows the system to switch to the shadow pages in the event of a failure, ensuring data integrity. Shadow packing can help achieve atomicity by ensuring that only complete and verified changes are made visible. Recovery algorithms. Various recovery algorithms such as ARES, and write head logging (WAL) protocol are designed to optimize the recovery processes. These algorithms help manage transactions, ensuring that they adapt the principles of atomicity and durability. Selecting the right recovery algorithm is crucial for balancing performance and reliability in the database system. Conclusion and best practices. Effective recovery strategies are essential for maintaining database integrity and user confidence. Implementing atomicity principles ensures that transactions are processed reliably and consistently. Organizations should regularly evaluate and update the recovery mechanism to adapt to evolving database technique and risk.
Thank you, sir.